In this problem, a 5-gram bullet traveling at 300 meters per second strikes and is embedded in a 500-gram stationary target, and we are asked to find the common speed of the bullet and the target after impact. So this is a perfectly inelastic collision. Why? Because the bullet and the target move as one system after the collision. And let's start by visualizing the problem. I'm going to draw a diagram for the initial situation and the final situation. I'm going to take right as positive x-axis, and this is the bullet. Initial speed of the bullet is 300 meters per second and mass is 5 grams. And I'm going to leave it in grams. You will see why. And this is the target. Target is moving. It's not moving. It's stationary. So speed is 0. Mass is 500 grams. And this is the final situation where the target and the bullet move as one system. And the speed is an unknown. That's what we're trying to calculate. But combined mass of the system is 505 grams. Okay, so the applicable concepts, this is based on conservation of linear momentum. Coordinate system is specified, and then symbol we are trying to calculate the final velocity. Meters per second is the unit. We expect a positive value, but anyways, this is the common speed, so it's a scalar quantity. Okay, so let's plan the solution. Initial momentum of the system is equal to final momentum mass times velocity. So we know that this system has the combined speed. For that reason, final velocity of the first object is equal to final velocity of the second object, and we can just use one variable, v final, to represent the final speed of the system. So I'm going to rewrite the equation with Vf as the final speed, and then we can factor out a Vf because it's common for both masses. So if you write an equation for the final speed, you will see m1 v1 plus m2 v2 divided by the combined mass of the system would be equal to final speed. So 500 grams times 300 meters per second plus 0, because the speed of the second object is initially 0, divided by the combined mass 505 grams. So that would be 1500 grams meters per second. Divide that by 505 grams. You can see why I didn't convert grams to kilograms, because we have grams on the numerator and the denominator. It's going to cancel out. 1500 grams meters per second divided by 505 grams, you will end up getting 2.97 meters per second for the final speed. So the solution is complete. We have done everything. Speed is a scalar quantity. So just see the steps. We visualize the problem and we'll plan it, and then only we executed the plan.